Great oaks from little acorns grow. Foundation and substructure are crucial parts in construction. From this lesson, we will start explaining the basic knowledge of foundation and substructure. The main task of this section is to master the basic concepts and design requirements of foundation and substructure. Understand the importance of foundation and substructure in architectural engineering and the learning methods of this course. Let's start learning the knowledge points together. We will explain the foundation and the substructure from three aspects: definition, classification, and design requirements. 1. Definition. Any building is supported on the stratum. After the stratum is subjected to the load of the building, the stress state of the stratum changes within a certain area. The stratum within this area is called foundation. That is, the part of stratum affected by the load of the building is called foundation. 2. Classification. First of all, according to the classification of rock and soil, the foundation can be divided into rock foundation and soil foundation. The rock foundation is composed of foundation rocks, such as hills. The rock foundation is buried shallowly or even exposed to the surface. Buildings in this area are often built on the bedrock. The soil foundation is composed of soil layers, such as bedrock, which is buried deeply and covered with thick soil layers on its surface. Buildings in this area are often built on the foundation composed of soil layers. When the foundation is composed of two or more soil layers, the soil layer directly in contact with the foundation is called the bearing layer, and the soil layer below it is called the underlying layer. The underlying layer, whose strength is lower than the bearing capacity of the bearing layer, is called the weak underlying layer. Secondly, according to whether the foundation has been artificially treated, the foundation can be divided into artificial foundation and natural foundation. Natural foundation is the foundation that can meet the design requirements without artificial treatment. Artificial foundation is the foundation that can only meet the design requirements after artificial treatment. Design foundation to meet three design requirements. 1. The foundation strength, also known as the foundation bearing capacity, means that under the action of the main vertical loads on the building, the foundation soil will not be damaged due to insufficient shear strength. 2. The deformation condition of the foundation means that the foundation cannot deform largely and affect the safety and normal use of the building. 3. The stability conditions of the foundation refer to high-rise buildings, towering structures and retaining walls that are often subject to horizontal loads, as well as buildings built on or near slopes. Since we need to verify the stability of the foundation, we have to verify the anti-slip and anti-overturning. 1. Definition. The lower part of a building is called the substructure. In order to ensure the strength and durability of the substructure, the substructure should have a certain burial depth, which refers to the distance from the design ground to the substructure base. Its function is to effectively transfer the load of the superstructure to the foundation. 2. Classification. Substructure can be divided into shallow substructure and deep substructure. According to different burial depths and construction methods, shallow substructure refers to the substructure whose burial depth is generally less than 5 meters and can be built only through ordinary construction procedures such as trenching and drainage. The burial depth of deep substructure is generally greater than 5 meters. Due to the large burial depth, we should take the friction resistance of side walls into consideration and use special construction methods in the design. There are various types of substructures, such as pile, substructure, and caisson. 3. In addition to meeting the requirements of substructure design, the substructure itself should also have sufficient strength, stiffness, and durability. From this picture, we can make a clear distinction between foundation and the substructure. Foundation and substructure are of great significance in engineering. First of all, foundation and substructure are located on the ground, which belong to concealed work and are important parts of the whole architectural engineering. The exploration, design, and construction quality are directly related to the safety, economy, and normal use of buildings. Once an accident occurs, it is difficult to deal with it, or even impossible to make a remedy. Secondly, the proportion of foundation and substructure, construction cost, and the construction period is related to many factors, such as the type of superstructure, the complexity of the structure, the number of layers, the seismic fortification category, the seismic grade, the engineering geological conditions, the construction conditions, and the construction methods, and many other factors, which can vary from a few percent to several tens of percent. 1. The course is the main course of civil engineering major, which is highly comprehensive. It not only involves engineering geology, geotechnical engineering, mechanics, but also involves knowledge of several disciplines such as architecture, structure, and construction technology. So, it requires extensive knowledge from previous courses. 2. Foundation and substructure is still a course with strong practicality and theory. Due to the different natural and historical conditions of foundation soil formation, its engineering characteristics are complex and diverse. 3. At present, fixing foundation and substructure engineering problems mainly relies on experience and experiments, supplemented by theoretical calculations. Therefore, there are many experience formulas, charts, and approximate calculation methods in this textbook. 4. The design of substructure engineering requires both rich theoretical knowledge and more practical experience. Through exploration and testing, we can obtain reliable data on the soil layers distribution and their physical and mechanical properties. Learning methods. When learning this course, we should pay attention to integrating theory with practice, adopt various learning methods through various teaching links, and closely combine engineering practice to improve theoretical understanding and enhance the ability to deal with foundation and substructure problems. Meanwhile, on the basis of consolidating the basic knowledge of soil mechanics and being familiar with geotechnical engineering exploration methods, you should master the working principles and structural requirements of the core contents of this textbook, such as foundation treatment, shallow substructure, pile substructure, etc. Finally, we should master the commonly used foundation treatment methods and working principles in civil engineering at present. Great oaks from little acorns grow. It's impossible to build a castle in the air. In study, work, and life, we should all be down to earth, seek truth from facts, and lay a good foundation for everything to pursue stable development. That's all for today's lesson. Thank you for watching.